Have you ever looked at a recession and thought, come on, why doesn't the government just step in and fix this? Well, if you have, you're in the right place. In today's Explainer, we're diving straight into the Keynesian mechanics, and yes, the actual math, behind how a government tries to steer an entire nation's economy back on track. Let's get right into it. Think of the economy like a massive, incredibly complex machine. When that machine inevitably slows down, people lose jobs, businesses shut their doors, and total production just drops. So to get it humming along again at its optimal level, which economists call full employment, the government has to step into the control room and pull the right levers. But here's the catch. There is no giant fix-it button. They have to carefully, and I mean carefully, calibrate the system using some very specific tools. Here's our quick roadmap for today. We'll start with an intro to fiscal policy. Then we'll look at our first lever, which is government spending, followed by our second lever, tax rates. Finally, we'll put it all together and see the math in action to hit that full employment target. Okay, part one, intro to fiscal policy. The absolutely crucial thing to understand here is that a government enacts fiscal policy by manipulating two primary variables. You've got government spending, which we'll just call G, and taxes, which we'll call T. The whole goal? To either expand or contract the nation's total income. So if the economy is acting sluggish, the government rolls out expansionary policy. They increase spending, decrease taxes, or maybe even do both to pump money into the system. On the flip side, if the economy is running too hot and inflation is spiking, they use contractionary policy. This is basically taking away the punch bowl just as the party gets going. They'll decrease spending and increase taxes to cool everything down. For this explainer, though, we're going to focus strictly on those expansionary tactics. All right, let's move to part two, lever one, government spending. Now, watch what happens to our initial aggregate spending when the government decides to, say, build a brand new highway, fund a massive research project, or upgrade the power grid. That kind of spending doesn't depend on what the current income is. It's what we call autonomous. Because of this, it causes a direct, parallel, upward shift of the entire spending curve. You literally see the equilibrium point move straight up, pushing our total income closer and closer to that holy grail of full employment. But wait, here is the absolute magic of the Keynesian model. That change in total equilibrium income, the delta Y, is not just a flat one-to-one match with what the government actually spent. No way. Thanks to the multiplier effect, represented by that little Greek letter alpha, a specific change in government spending actually results in a multiplied change in overall income. Think about it like this. The government pays a construction worker, right? That worker then goes and buys groceries. The grocer takes that money and buys new clothes. The initial spending ripples outward, multiplying its impact across the entire machine. It's a real game changer. Moving right along to part three, lever two, tax rates. Now, this lever is fascinating because unlike government spending, tweaking the tax rate does not cause a neat parallel shift. Instead, it actually alters the slope of the aggregate spending curve. Makes sense, right? Taxes take a specific percentage out of every single dollar earned. So if the government decides to lower that tax rate, everyday people get to keep a larger fraction of their income to spend. And as they spend more of each dollar, that aggregate spending curve gets noticeably steeper. And by changing that slope, the tax rate is directly influencing the multiplier itself. Unlike just a flat injection of cash from government spending, altering the tax rate actually changes the fundamental momentum of how money flows from person to person. Lowering taxes pumps up the multiplier, accelerating that ripple effect of spending we talked about earlier. And that leads us to an entirely new, significantly higher equilibrium income point. So when taxes change the multiplier, we use this master equation to find the new equilibrium income. I know, it looks a little intimidating at first glance, but it is beautifully logical. The new income level is simply equal to our new multiplier, alpha, multiplied by the sum of all our autonomous variables. That's consumer spending, investment, government spending, and exports minus imports. It essentially captures the entire economic machine in just one elegant line of math. Which brings us to part four. Math in action. Full employment. Let's see this in the real world. Okay, let's put this theory to the test. Here are the starting metrics for our hypothetical economy. We've got our baseline consumer, investment, and government spending laid out, along with our rates. But I want you to keep your eyes on that number at the very end, 2,500. That is our target. That's the full employment income we need to reach to have a healthy, thriving economy. Now, when we take those starting variables and plug them into our master equation, we immediately spot a serious problem. Our current income is sitting at just $1,350. But remember, our target for a fully employed economy is $2,500. That means we are facing a massive income shortfall of exactly $1,150. We absolutely have to bridge this gap. But here's the good news. We don't actually have to spend $1,150 to close it. Based on our tax and consumption rates, the math shows we have an economic multiplier of 2.5. So every single dollar the government spends is going to generate $2.50 of total income. So what's the actual fix here? Well, if you divide our $1,150 shortfall by our 2.5 multiplier, it reveals that the government needs to increase its spending by exactly $460 million to achieve full employment. Boom! That is the sheer power of the multiplier. A $460 million injection from the government ripples all the way through the economy, multiplying by 2.5, filling that entire $1,150 income gap and nursing our economy right back to full health. But, and this is a big but, if changing government spending or taxes to fix income is this clear on paper, why is it so incredibly difficult in reality? While our little textbook exercise makes saving the economy look like a perfectly clean mathematical equation, it kind of leaves you wondering why pulling these levers in the real world is infinitely more complex. Think about it. In our math problem, all those variables just stood perfectly still. In reality, consumer confidence shifts wildly from day to day. Businesses hesitate to invest. Global trade is constantly fluctuating. And actually getting government spending approved can take years of political debate and red tape. If the math is a perfect map, reality is the messy, unpredictable terrain. So I'll leave you with this. Are we truly the masters of the economic machine? Or are we just trying to steer a massive ship while we're still building it? Thanks for joining me for this explainer.